And here we go. So guys, these are the topics for your notes today. Guys, we've got lab skills, techniques, concepts, and calculations. The date today is the 28th. And guys, I will always do this for you. I'll always give you a topic for your notes. I will always introduce what we're going to do for the day, which I've already done by looking at the calendar. You understand that we're going to gather up your math skills and we're going to fine-tune them, and we're going to show you how to use the equipment in lab in preparation for Thursday, so you know what we're doing. And then guys, I'll always give you the date so you can keep your notebooks in chronological order, because you know that being organized is one of the keys to being a good student. By the way, if any of you actually believe that that's true, that whole organization is key to being a good student, if you could teach that to my 17-year-old son, that would be glorious, because he won't hear it from me. He's convinced that it doesn't actually work. Okay, so guys, this is our laundry list of stuff. We're going to talk about skills, techniques, concepts in math, and you are going to have a little bit of homework tonight relative to the math, and then we'll be all done. You guys ready to go? Okay, so guys, first of all, skills. The first skill that we need to develop, and I would write this down, is lighting a Bunsen burner. And guys, so I'm going to teach you 4 skills. I'm going to have you write down the first one and the last one. I do want you to write down these steps, because this is probably the hardest, well, it will be. This is surprisingly difficult. So guys, let me give you the steps. You can take your notes with you into lab on Thursday. So when you get in there and get really frustrated because your Bunsen burner won't light, here's what you're going to do. Step number 1, you're going to shut down the burner. And guys, again, I really would encourage you to, there's only 6 steps. They're short, but I would encourage you to write these down. So step 1 is shut down the burner. Then guys, step 2 is turn on the gas. Then step 3, and I know I'm going fast, you'll see, just write them down. Step number 3 is open the needle valve. Then guys, after that, step 4, light the burner. And again, guys, forgive me for going fast. I promise I'll pause and let you catch up. Step number 5 is adjust the flame. And there are 2 adjustments that you can make to the flame, height and heat. In order to adjust the height, you're going to change the valve. In order to change the heat, you're going to mess with the barrel. And then guys, finally, and this is important, when you're all done with your Bunsen burner, shut it off at the tap. It's not enough to shut off the burner at the valve. They leak and fill the school with gas. That's bad. All right. You guys okay? I can wait. Did any of you print the notes? When did you try? How late? Yeah, that's my fault. Miss Call and I were wrestling with how we wanted to teach this material, and she finally got done with soccer practice about 6, and we sort of texted back and forth. I didn't post the notes until like 7:30. So I'm sorry, that's my fault. Okay, you guys ready to do this? Okay, so guys, when you walk into lab tomorrow, Thursday, this is what you're going to see. Every one of your lab stations has this. This is what is called a ring stand. The reason that it's called a ring stand is because there's a metal ring on there. So all of your stations have a ring stand, and then they've got a test tube clamp up here, and then they've got a Bunsen burner. The other thing that you need to be able to find in order to light your Bunsen burner is this. It's called a hooded striker. In your stations, these actually live right here on the back of the faucet. Please don't put them in your drawers. Hang them here here because these are community property. So guys, in order to light your Bunsen burner, the first thing you need to understand is how these things work. Feel free to touch these. It's not like you just sort of leave it on the table. Guys, pick these things up. Don't unplug them like I just did. You don't need to do this. And what you'll see is the other end of this hose is actually hooked up to the natural gas tap. Don't mess with the hoses. If we get leaks in the hoses, that's bad. But I'm going to do this just to show you how these work. So guys, a Bunsen burner is actually made of 3 parts. It's a barrel, it's a base, and it's a needle valve. Don't do this either. I mean, it doesn't hurt anything. You'll just never need to. So the way this works, guys, is the gas goes in the side of the burner, makes a left-hand turn, and goes straight up. And the gas comes out of this little bitty hole that is called a jet. Now, guys, this is what is called a needle valve. And you'll notice, if you can see it, that it comes down to a very tight point. When you screw this in tight, that little point sticks inside of the hole, and it shuts off the gas. So when you pick up your Bunsen burner, that's the first thing you're going to do is screw this tight so that the needle is in the hole. Then the next thing you're going to do, and you shouldn't take the barrel off, but you'll notice that there are holes in the side of the barrel. What you're going to do next is you're going to screw this all the way down so that the holes in the barrel are closed as well. So the needle valve is closed, the barrel is closed. That's called shutting down the burner. You get the idea? Okay. Now from there, here's what you're going to do, and now I need to hook this up to gas. So we plug in the gas here, and we plug in the gas here. And guys, for your stations, yours don't look quite like this. In your lab stations, the gas taps are horizontal. Mine are vertical, doesn't matter. But guys, step number 2 is to turn on the gas. And here's the way this works. You've got the schnozzle, for you it's horizontal, mine's vertical, and then you've got a valve handle, this guy. Anytime those things are perpendicular, they're shut off. So this is off, this is off. When they are aligned, it's now turned on. So guys, I have now turned on the gas to the Bunsen burner. But you'll notice you don't hear gas flowing. Why not? Why is there no gas flowing through the burner? Because it's shut down. So now guys, step 3, open the needle valve. Do this. Pick this thing up, because guys, it's going to be loud in lab. You can even hold it next to your ear. And what you're going to do is you're going to open this until you hear gas flow. Can you hear it? Okay, so I'm going to shut this down again so I don't fill the room with gas. If you were doing this, you would leave that on. Now we've got gas flowing through the burner. Now you're going to light the burner. And guys, we don't give you matches to light the burner because then we get a trash can full of matches. So we give you strikers. And guys, you can squeeze this thing until tomorrow and it will never make a spark until you do this. And then it makes lots of sparks. So here's how you do this. Ready? You're going to make a left-handed gun, right? You don't have to do this with me if you don't want to. But guys, this is how to, it's got to be left-handed. Okay, here's how to make this thing spark. You're going to get a left-handed gun, and then you're going to make it a gangster gun. Okay? So you're going to get your left-handed gangster gun, and then you're going to put the hood of the striker against the barrel of your gun. So left-handed gun, gangster gun, put this against the barrel of the gun. Then you're going to hook your thumb on this arm of the striker, and you're going to squeeze so hard that it leaves a crease in your thumb. And when you do that, what you're doing is you're taking this flint and you're driving it into this scrapey part that's inside the hood. So again, guys, gangsta gun right here, squeeze hard, make sparks. You get the idea? Okay, so what you're going to do then is gas on, we opened it up, the gas is flowing, gangster gun, squeeze, and you just lit the Bunsen burner. For some of you, this is going to take between 30 and 60 minutes. You're going to, it's actually, I'll come and help you. It's sort of depressing to watch. But guys, understand, some of you are really going to struggle with this, and that's not necessarily bad. Eventually, you'll get good at this. But guys, here's the trick. Once you get there, the victory is not won. Because guys, this flame is so inefficient that it will never boil water. It will never do the things that you need a Bunsen burner flame to do. It's not a hot flame. So what do you do to make it hot? Well guys, here's the answer. Right now, the combustion is just taking place up here. So air is coming in from the room, mixing with the gas, and it's burning. And that's not very efficient. So guys, what we've got to do is we've got to mix more air into the mixture before it combusts. It's kind of like a carburetor or a fuel injector in a car. And here's how you do it. Grab the barrel at the bottom, and this is about adjusting the flame. Grab the barrel at the bottom and turn it open. Don't grab the top. It's hot. Grab the bottom, and guys, watch what happens. As I screw this open, see how the flame changes? Guys, you stick your hand in that flame and you're done. This is a very, and I wonder if you can see this. I think I can shut my projector out. Yeah, like this. So guys, can you see that flame? Can you see that there's an outer like purple halo and a very tight inner blue flame? Guys, that point right there at the top of that inner blue flame is the hottest part of the flame. So what you want to do is adjust this flame until that hottest part is about 1 inch tall. So right now it's too tall. So because it's too tall, I need to adjust the height by adjusting the valve. So I grab this valve at the bottom, and if I add gas, it gets taller. And if I remove gas, it gets shorter. And then guys, if my flame is too yellow, I need to add more air. And eventually, this is the flame that you're looking for. Then what you're going to do is this. You're going to grab your ring stand. You're going to set this on your ring stand. And you're going to adjust the height of the ring until the very tip of that flame is like level. Well, this is a little too high now. There we go. So you're going to adjust the tip of the flame until the tip of the flame is level with the ring. Then set that there and you're ready to go. You get the idea? Then guys, when you're done, you shut off the gas at the tap. Do not shut off the gas at the burner. Shut it off at the tap because that's the only valve that is actually truly tight and will keep the gas from flowing. Bunsen burners? You guys good? All right. So guys, we're going to do that on Thursday. Okay. So guys, continuing to talk about skills. Balance. Please write this down with me, but you're not going to take many notes. I'll show you what to write down. So guys, when we talk about a balance, what we're talking about is this. It's a scale. It's a balance. But this is the device that we're talking about. And there are some things you need to understand in order to make these things work properly. So I'll tell you what to write down. So guys, first of all, never put chemicals on the balance. What if we don't write that down and just agree we're not going to do that? Okay? Guys, never put chemicals on the balance because they will eat holes in the pan of the balance. So instead of putting chemicals on the balance, what we do is we use one of these, which is called a weighing boat. These are disposable. When you're done with them, most of the time we'll throw them out. But guys, the thing that's neat about these weighing boats is if you pinch them from the corners, they actually make a little spout and you can pour out of them. So you'll never put stuff directly on the balance. You'll always use a weighing boat if you need. Then guys, number 2, please write down the word tare button, T-A-R-E. So guys, every balance has what is called a tare button. Next to tare, please write down re-zero, because that's actually what our balances have, is a re-zero button. So guys, here's the trick. Every time you walk up to a balance, hit re-zero. Just get in the habit. Before you do anything, you're going to come up here, and it's the button on the left. Guys, you're going to hit the re-zero button. Just get used to it. Every time you touch a balance, you will always re-zero it first. And guys, all the ReZero button does is literally sets the balance back to 0. And we'll talk more about that later. And then guys, you don't need to write this down, but let's make sure you're clear. Remember how we said when we take measurements, we always estimate 1 decimal place past the accuracy of the device? Guys, you can't do that on a balance. If you look at a balance, the balance has a digital readout. And because it has a digital readout, there's no way to estimate because it's just telling you the measurement. So guys, when you come up to a balance, you'll hit ReZero, put on a weighing boat, make the measurement that you need, and all you do is record the value that's given. You okay with that? We're going to talk more about it later, but here are the important points. Never put chemicals on the balance, always tear in ReZero, and you don't make estimates with balances, you just write down the numbers. So guys, let me give you a second. Any of that you want to jot down that you didn't, go ahead and do that. But guys, it's important for you to know, never chemicals on the balance, tear a ReZero, and don't estimate. You good there? All right. So guys, now number 3, reading a graduated cylinder. These are terms you need to know, so there are a couple things that you need to write down here. So guys, this is a graduated cylinder. This is what it looks like for real. This is what it looks like digitally. But guys, this is a graduated cylinder. We use these to measure liquid volumes. And they actually measure pretty accurately. So what you need to understand is how to make accurate measurements with a graduated cylinder. These are things that you need to write down, include them in your notes. So the first thing is this. This is a term that you need to know. It's called meniscus. For those of you that have taken biology, you probably understand capillary action, that water is drawn up the sides of a tube. And guys, when that happens, it creates what is called the meniscus. This is that concave up surface on a liquid in a cylinder. And guys, we need to talk about how you deal with the meniscus. And we'll talk in a minute. Then guys, the second thing that you need to understand when using a graduated cylinder is about parallax. Parallax is error in measurements that are caused by misalignment. And I'll show you what that means in a minute too. And then guys, finally number 3, do estimate 1 decimal place past the scale of the device. You could just write down do estimate. So guys, with all of that said, this is, and you're going to be using a graduated cylinder on Thursday. Volume measurements in a graduated cylinder. Well, guys, you'll see when you get over there, and I know you can't see this from here, but there is actually a dip on the surface of this water, and you can see it in the picture as well. If you look at this, you can see that there's a dip in that, and again, that's because the water is drawn up the sides of the cylinder. So guys, the question is, relative to the meniscus, where do you measure from? And guys, the answer is the bottom. You will always measure from the bottom of the meniscus. So if you want to make note up where you wrote down meniscus, if you want to write down the word bottom, you'll always measure from the bottom of the meniscus. But guys, when you do that, you need to avoid what is called parallax. So let me show you what I'm talking about. Say that I want to measure the volume of this water, and I've got it here, and I set it on the table, and I do this. Do you see the problem? What's wrong? I'm measuring at an angle, right? And if I come at it like this, my measurement's going to be too low because I'm looking at it in an angle. So guys, that's what parallax is. It's error in measurement caused by misalignment. So guys, what do we do to fix parallax? You got 2 choices. Pick up the cylinder, drop your butt. Either one is fine. And guys, I think you're going to find drop your butt in lab is a better option because your countertops are this tall. And if you pick this up, you're going to be all like shaking and stuff. So if you just leave this on your counter and then drop your butt, you want to get down eye level when you're making measurements. Does that make sense? Okay. Then guys, what about this idea of estimating? Well, join me at the board. So guys, in order to make a proper measurement, you need to understand the units of the scale. So you'll notice that we got these units that go 30, 40, 50. So if those units go 30, 40, 50, what do each of the lines represent? Ones. So guys, if the lines represent ones, what measurement are we going to make when we record it? Tenths. So here's how this goes. This is 40, 41, 42, 43, 44. So if we were making this measurement, we'd go 44. But if you just write down 44, that's wrong because you need to estimate tenths. So 44 point what? What would you write down? 8, 9, 7? Guys, you can't get that part wrong because it's an estimate. So if I were looking at this, what I like to do is I like to imagine where the 0.5 is. And if 0.5 is in the middle, it looks to me like it's about half of the half. So I would do like 44.7 or 44.8. But you're going to estimate one decimal place and then put units on your numbers. Does that make sense? Okay. So guys, here's where we are. We've done Bunsen burners, we've done balances, we've done graduated cylinders. We got one more to go. You good? Okay. So guys, the last one that you need to know how to use is a filter. And guys, there are 6 steps to using a filter. I'm going to give them to you, and then I'm going to show you. So guys, when you filter, these are the 6 things that you need to do. Take the filter paper, fold it in half. Then do it again. I would write these down because these you're going to want to have when you go next door. Take a piece of filter paper, fold it in half. Then guys, you're going to fold it in half again. Then what you're going to do is open it up between pleats 2 and 3. Or 1 and 3, sorry, 1 and 3. Then guys, you're going to clip the corner of the outer pleat. Then you're going to put it in a funnel and get it wet. Then guys, once you've done all of that, you just need to be careful that you don't pour over the filter paper when you're using it. How you doing? Are you there? Are you okay? Oh, sorry. Now you're all wishing you printed the notes. Y'all caught up? So guys, let me show you how this works. What you're going to find is that when we go to lab on Thursday, you are going to have a mixture that will include a liquid and a solid. And you're going to have to separate the liquid from the solid, and we do that by filtering. So here's how to take this piece of filter paper and turn it into a filter. So step number 1 is fold it in half, like so. Step number 2 is do it again. So now you folded it in fourths. Then guys, when you look at this from the end, what you're going to do is you're going to stick your fingers in here between pleat 1 and 3. So the difference is this: if you stick your finger in here so that you've got 2 pleats on both sides, it's just going to unfold. So what you're going to do is you're going to stick your finger in here so that you've got 1 pleat above your finger or below. And so 1 on one side and 3 on the other. Could be here, could be there, doesn't matter. But you're going to get 1 pleat and 3 pleats. And when you do that and then open this up, all of a sudden you've got something that's shaped like a cone. Then what you're going to do is you're going to get this outside pleat right here, and this is step number 4, and you're going to rip it off. Don't take a big chunk, but you're going to rip that corner off, and now you've got this. And once you've got that, this thing magically fits inside of your funnel. Now guys, the reason that you clip that corner is because when you tear that corner, it allows the paper to sit flat against the funnel. So now you've got your filter paper in your funnel, but the problem is if you let go of this, it just snaps back up and makes a mess. So what you're going to do once you've got this all situated is you're then going to put a little bit of water in it, slosh it around, and then it will stick to the sides of your funnel, and now you've got a filter that you can use. You can dump that solid liquid mixture through, the liquid goes through and the solid stays in the filter paper. Get the idea? And then guys, when you're done, you're going to see in lab on Thursday, we don't care about the solid, so you can just pick that out and throw the solid in the trash. Okay, so guys, those are all the skills that you need. Bunsen burners, balances, graduated cylinders, filters. You good? Okay. So now guys, the next thing we need to talk about are techniques. Don't take notes. Do write down techniques. But guys, trust me on this. I'm not having you skip taking notes because this isn't important. I'm having you skipping taking notes because it's so important. I want you to see this and think about it rather than get all caught up in writing stuff down. So guys, you need techniques when it comes to dispensing liquids and dispensing solids. So guys, we're going to talk about liquids first. Again, please just trust me. Don't write this stuff down. So guys, it goes like this. When we dispense liquids, sometimes you need a lot and sometimes you need a little. And guys, I'm going to gently hold you accountable to this, but this is what you need to be able to do. So guys, when you go into lab on Thursday, when you go into lab, sometimes you're going to find there are just bottles of liquids sitting around out on the countertop, and there's just liquid bottles everywhere. And these are different chemicals, and sometimes you're going to need a lot and sometimes you're going to need a little. So guys, when you need a lot of a liquid chemical, you are going to pour it. Please don't write down the steps, but when you pour a liquid, these are the things that you need to keep in mind. First thing you're going to do is you're going to take off the lid and you're going to palm it. I'll show you what that means in a second. Then guys, when you dispense, you never pour back into the stock bottles. If you do, you're going to contaminate everybody's lab. Never let me see you pouring back into a stock bottle. Then guys, you'll always put the lid back on the bottle, and when we do this, we'll use a graduated cylinder. So guys, these are just water. This is all just distilled water. So say that we need 15 milliliters of this liquid, and this is just water, but whatever it is, guys, here's what you're going to do. First thing you're going to do is you're going to screw the lid off. Never sit it down. So guys, why do you never set the lid down? Because if we've got this bottle and its lid is down, and this bottle and its lid is down, and its bottle and its lid is down, and we get all these bottles all over the place, you see the problem, right? When we're done, we don't know which lid goes with which bottle. So you never set a lid down. There should never be a bottle lid on the counter ever. So guys, here's what you do. You grab the bottle, you take the lid off, and then what you're going to do is you're going to take the lid and you're going to stick it in the palm of your dominant hand. Then you're going to grab the bottle with the lid in your hand, and that way you never set the lid down and you always know which bottle the lid goes to. Then guys, what you're going to do is this. You're going to come along and say if we want 15 milliliters, we're going to go 15 milliliters. And I should be like down and like doing my parallax thing, right? But well, here I can do it. So we're going to go like this. We're going to get 15 milliliters. Now guys, what happens if I get too much? Do not ever pour back into the stock bottle. I'll tell you what to do. If it's safe, we'll pour it down the drain. If it's dangerous, I'll have a waste beaker back in the fume hood. But guys, never pour back into the bottle. If you get a little bit too much, you can pour it away, but never pour back into here, and we'll always use a graduated cylinder. You get the idea? Okay. Now guys, what if we want just a little? What if we want like a milliliter of a liquid, which is actually smaller than this can measure? This actually doesn't even go down to 1 milliliter. Well, guys, if you want small volumes of things, what you do is actually called transferring. And you will always use what's called a transfer pipette that'll be attached to the bottle. And this is the way to do it. You squeeze the pipette, you fill it up. Then you dispense the liquid back into the bottle until you get down to the desired amount. Then you transfer that wherever you need it, and then you return the pipette. So here's how it goes. Again, guys, this is just water, but this is what is called a transfer pipette. And guys, on the side of this, there are marks, and the top mark is a milliliter, so it's 0.255, 0.75, and 1 mill. So say we want a milliliter. Guys, here's what you're going to do. So this is going to be stuck to the side. You come along and you set the lid down. Put the lid in the palm of your hand. Then, guys, you grab this dropper, you squeeze it, you stick it in here, and you overfill it. You literally slurp as much in here as you can. Then, guys, if we want a milliliter is the very top mark. And what you're going to do then is you're going to go drip, 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 drip. And you're going to drip this down to a milliliter. Now, guys, are we violating the rule that says never put stuff back in the bottle? But why is that okay? Yeah, because this dropper has only been in this bottle, so we're not contaminating. So we're going to drip this down to 1 milliliter. When the meniscus is sitting on 1 milliliter, we'll then let go, suck that amount of liquid up into the bulb, take this wherever we want it, dispense it into our test tube or whatever else. So we'll come along, we'll dispense the liquid that we need, and then, guys, we just put this back in here, we screw the lid back on, and we're good. You get the idea? Okay. So, guys, big amounts of liquid, small amounts of liquid, you okay on those? Okay. Now, guys, we got to talk about solids. How do we measure and weigh solids? And so, guys, don't write these down, but here's the deal. This gets tricky because we've got to avoid contamination. And again, never put chemicals on the balance. We'll use a weighing boat. And guys, we are going to use what is called the tap method to dispense these solids. And well, I'll show you more about how that works in a minute. But again, guys, never pour back into a stock container. You'll always use a spoon. So you'll always just get rid of it. So guys, here's the way this goes. Say that I want 1 gram of salt. So here's some salt. Here's a weighing boat. And say that I want 1 gram of salt, and I've got a big old stock thing of salt, and I need a spoon, and then say that I want 1 gram of salt. So guys, how am I going to weigh out this gram of salt? Well, the first thing we're going to do is we're not going to put the salt on the balance. So guys, what we're going to do is we're going to come up here, the balance will turn on. Okay, and now we need our gram of salt. So what I'm going to do, guys, is I'm going to put this weighing boat on the balance. What is the balance now telling me? The weight of the weighing boat, but I don't care about that, right? So what I'm going to do is I'm going to hit re-0. Now the balance says 0, and it's subtracted out the weight of the weighing boat. So now what I can do is I can take my spatula, and I can come along, and I can tap up to 1 gram. This is called the tap method. Now, guys, oh crap, I went over. Guys, what do you do if you go over? Well, here's what we're going to do. Guys, this is extra that I know that I don't need, and I can't put it back in here, right? Because this could be contaminated. So, guys, what'll happen is a lot of times I'll give you a spatula that only goes with that chemical. So if this is your spatula, it goes in the trash. If this is a spatula that's only attached to this, you can put it back. But this is my spatula, so I'm going to get rid of it. But now this is too much salt. So what are you going to do? Take some out. So guys, what you're going to do is pick this up, take some out. Then you put it back on, and now it weighs less than 1 gram. Then what I'm going to do is add some of this back until it's now exactly 1 gram. Now guys, just a second, what do I do with this now? This I can't put back no matter what, because that weighing boat could be contaminated. So in either case, this I throw away. Yeah? You need to put your foot down. What? Say it again. It does. So when I pick this up, actually, think about this. When I pick this up, guess what the thing reads? A negative mass. It actually says negative 2.28 grams because it's subtracting out the mass of the boat. So when I put it back on, it remembers the mass of the boat, and that would be 1 gram. Now, guys, you ready for a deep thought? This says 1.00 grams. Does that mean that this salt actually weighs 1.00 grams? What did you learn from grading the homework? Remember the question with the beaker and the sugar? Guys, we don't know that that balance is accurate. This may not weigh 1 gram. So guys, what can we do to guarantee that this salt actually does weigh 1 gram, or to know it's weighed accurately? What are we going to do? Go ahead. Not quite the boat thing. What we're actually going to do is weigh a beaker and then put this in the beaker and then weigh the beaker in the salt and then subtract, and that will fix our maybe broken balance, and then we'll know the mass for sure. Did that transition make sense? Because guys, that's the next thing in your notes. Transition with me. Goes like this. Concepts and calculations. This you do want to write down. So guys, what Lauren just described to us is what is called finding mass by difference. Finding mass by difference. Do write that down. So I think that salt weighs a gram, 1.00 grams. That's what my balance told me. What we're going to do right now is we're going to find out whether or not it really does weigh a gram. Now guys, don't write this down, but if you're not sure what we're up to, here's what we're going to do. As we said before, when we use a balance, guys, we understand that these balances may not be accurate because they may just not work properly. But guys, here's the trick. We can overcome this issue. We can take, as we demonstrated in homework today, we can take a broken balance and make it work. And we do that by finding mass by difference, just like question number 3 in the homework that we graded today. Guys, we are going to actually find out what this salt weighs by finding the mass by difference. So guys, do this with me. Write this next part you want to write down. So guys, what we're going to find is this. Write it down with me. We're going to find the mass of the beaker. Then we're going to find the mass of the beaker and the salt. Then how do we find the mass of the salt? By subtraction. And guys, I'm going to show you how to represent this, and we're going to be doing this for the rest of the year. This is an essential. This is a skill that you're going to be tested on at the unit test. If you can't do this, you're going to be doing remediation. Guys, this is important. This is a skill you've got to have for the rest of the year. So it goes like this. In order to figure out the actual mass of this salt, and this is what you're going to be doing in lab on Thursday, by the way. Guys, we need to weigh the beaker. What do I have to do to the balance first? Why is that especially important now? It's right. It's memorized the mass of the weighing boat. So I'm going to come along and I'm going to hit re0. And then I'm going to put on the beaker, and it's 29.72 grams. So I'm going to record that piece of data, 29.72 grams. Guys, notice that I'm not estimating a digit because I can't. It's a digital readout. Now, guys, does that beaker really weigh 29.72 grams? We don't know. It could be wrong. That balance could be off. But we know that the balance thinks it weighs 29.72 grams. Now, guys, here's what we're going to do next. How much do we think this salt weighs? A gram. So what we're going to do is we're going to grab the beaker, we're going to pinch the weighing boat so it turns into a spout, and we're going to dispense that salt into the beaker. Now we're going to re-zero the balance again, and now we're going to put this on on the balance. And guys, this is now reading 30.70 grams. Now we can find the mass of the salt. And how do we do it? Subtract. Now guys, listen to me. It matters how you do this. There's an accepted way in science to show mass by difference calculations. I'm going to show you, and this is the way you're going to do it for the rest of the year. So guys, do this with me. Here's what we're going to do. Write this down with me. We're going to go mass of the beaker and the salt. From that, we are going to subtract the mass of the beaker, and that will then give us the mass of the salt. And guys, that is always the way you will represent mass by difference calculations. The total masses minus the mass of the container gives you the mass of the stuff you care about. Then guys, we're going to skip a little bit of space, and we're going to get our numbers. So the mass of the beaker and the salt, 30.70 grams. The mass of the beaker and the salt is that. The mass of the beaker, 29.72 grams. You'll notice that my decimal places line up. And when we do that subtraction, we get 0.98 grams. So guys, we thought it weighed a gram. It turns out it only weighs 0.98 grams. But how do we know that that number's correct? How do we know the 0.98 is correct when the 1 maybe wasn't? It's all about where it came from. Guys, we demonstrated in homework that if a balance is inaccurate, you can still get accurate readings by finding mass by difference. And that's what we've just done, and that's always the way we'll find masses. You get the idea? You good? Okay. So guys, one last thing to do, and we're going to wrap up the day. So the last thing that we need to talk about is when we do math, because we're going to be doing a lot of math in lab. The question is, how do we deal with significant digits in calculations? Guys, you need to write this down. These are the rules. And I'll show you examples. So guys, the rules are these. For multiplication and division, when you're multiplying and dividing, the rule is this. You get as many significant digits in your answer as the least accurate number in the calculation. And guys, I'll show you what that means in just a minute. But guys, here's the thing that's interesting. When you're adding and subtracting, the rules are different. When you're adding and subtracting, you don't care about significant digits, you care about decimal places. So you can serve decimal places, not significant digits. And I'll show you what that means in a second. And then I'll show you a couple simple examples. Then we're going to apply this rule together. And then guys, you'll have a few minutes to work on your homework. So guys, I would encourage you to write down these two examples with me. So example number 1 goes like this. 125.50 grams times 2.23 grams. So guys, let's do the math. 125.5 times 2.3, the answer is 288.65. Just write it down with me. You can do that math on your own, but I'll just show you the answer. So guys, the answer is 288.65. But guys, that answer is wrong. That answer is wrong because it has too many significant digits. So look at what we've done. We have multiplied. And when we multiply, we have to round to the fewest significant digits. So guys, do this with me in your notes. 125.50, how many significant digits are in that number? Show me on your hands. How many significant digits are in that number? Is everybody in agreement on 5? Why is that 0 significant? Final 0 after the decimal. So guys, this is in fact 5. How many significant digits in 2.3? Show me. It's all 2, right? So guys, this is the deal. You get the fewest. So if we've got 5 and you've got 2, you get 2. So what we have to do is we have to round this number to 2 significant digits. So here's 1 digit, here's 2 digits. What does the next 8 tell you to do? Round up or leave it alone? Round up. And so guys, this number rounded to 2 significant digits would actually be 290 grams. That's the answer that you would repeat. Is that okay? But now guys, watch this. Addition and subtraction are different. Same numbers. Write it down with me. But now instead of multiplying, we're subtracting. 125.50 minus 2.3. And guys, you can do the math. 123.20. But now guys, this is where this gets interesting. When you're adding and subtracting, you do not count significant digits, you count decimal places. So guys, in this number, we have 2 decimal places. In this number, we have 1 decimal place. Decimal places and not significant digits. So you still get the fewest. So we only get 1 decimal place in our answer, and we round to 1 decimal place. So this number rounded to 1 decimal place is just 123.2. So multiplication and division, significant digits, addition and subtraction, decimal places. So guys, we're going to do one more thing. We're going to apply these ideas in a new situation. This is the last thing for today, and it's the last thing that you're going to be doing in your lab write-up for Thursday. So let me introduce the concept to you. We'll solve one together, and then you'll have a little bit of time for homework. So guys, it goes like this. What we're going to do is talk about something called percent error. You guys write this down with me. So guys, in many of the labs that we do throughout the year, the very last thing we're going to do is we're going to figure out how bad did we do. And I know that sounds horrible, but that's what we do as scientists. Guys, when we're done with the lab, we're going to sit down and look at our data and we're going to go, man, how off were we? And in order to calculate how off you were, you're going to use this equation, which is called the percent error equation. Write it down. So this equation is your measured value. The measured value is your value. And then guys, you're going to subtract from that what is called the accepted value, which is the correct value. And then you guys know what the vertical lines mean, right? What's it mean? Absolute value, which just means always positive. And then you're going to divide that by the accepted value, and then you're going to multiply that by 100. And guys, the measured value is your value. It's the value that you measured or calculated. And then, guys, the accepted value is the real answer. And this is how you figure out how bad you did, how big was your error. So you're looking for small numbers. You want your errors to be small. So guys, we're going to solve one of these, and then we're going to wrap up the day. And again, guys, you will be doing this on Thursday. This will be the last calculation that you'll do in lab on Thursday. By the way, guys, as I'm thinking about it, if you didn't bring your goggles last time, you're okay. I know a couple of you brought them today. Leave them in your backpacks. Bring them on Thursday, because if you don't have your goggles on Thursday, I can't let you go to lab. If any of you don't have goggles for financial reasons, guys, please come talk to me. I'd love to help you out. Okay, guys, let's look at an example, and then we'll wrap it up from here. So guys, the question says something like this. Don't write it down, just read it with me. It says, a chemist reacts some sodium metal and some chlorine gas together in a closed container. This person expects to collect 17.2 grams of product. However, he only collects 13.85 grams of product. What's the percent error? So he only collected 13.85 grams. He thought he was going to collect 17.2 grams. How bad did he screw up? Well, guys, we're going to calculate it. Write this down with me. Here's the rule. Anytime you use an equation in this class, you write it down. Every time. No apologies, no exceptions, no excuses. So, guys, do this with me. Write down the equation. So percent error is measured minus accepted divided by accepted times 100. Now, guys, step number 2 is to plug in numbers. So let's talk. The measured value is how much he actually got. How much did he actually get? 13.85 grams. How much did he expect to get? 17.2. So, guys, let's plug in those numbers. So 13.85 grams minus 17.2 grams. Notice there are units on my numbers. Divided by 17.20 grams, and then that's times 100. Now, guys, we need to apply the rules that we learned last time, 3 minutes ago. So in order to solve this, we're going to do the subtraction first. Guys, join me at the board and let's talk. The first thing that we're going to do is 13.85 minus 17.2. And when we do the math, here, well, go ahead and do the math. So guys, 13.85 minus 17.20. Do the math in your calculators, but don't write anything down. Let's talk. So guys, here's the question. When we do subtraction, we don't care about significant digits. What do we care about? Decimal places. So how many decimal places here? 2. How many decimal places there? 2. How many decimal places in your answer to the subtraction? 2. Oh gosh, the animation's out of order. Just a second. Sorry, guys. Just a moment. So, guys, what's going to happen then is... Here, let me just bring it all up because the animations are messed up. So guys, it goes like this. When you do the subtraction, we've got 2 decimal places, 2 decimal places, so we get 2 decimal places. So the answer to that is negative 3.35, and that's 2 decimal places. But that's still divided by 17.20. So now, guys, what we're going to do next is we're going to do the division. And we're going to go negative 3.35 divided by 17.20. But now, guys, join me up here. This is important. Now we've got to watch significant digits. How many significant digits in 3.35? There's 3. How many significant digits in 17.20? 4. So how many do we get in our answer? 3. The fewest, and that would be 19.5. Now, guys, what happened to the negative sign? Exactly. It's absolute value, and it goes away. So guys, we did a lot today. We talked about how to use a Bunsen burner, a balance, a graduated cylinder, and a filter. Then we talked about how to dispense lots of liquids and a little bit of liquid and solids. Then we talked about how to find mass by difference. We talked about how to deal with digits in multiplication and division and subtraction and addition. And now you understand percent error. That was a lot. Now guys, here's the deal. Most of the stuff that you learn today, you're going to just start to practice with when we go to lab on Thursday. That said, you do have homework. Guys, go to the homework section of your notebook. So guys, looking at the homework section of your notebook, we are now looking at assignment number 2. And you'll notice that assignment number 2 is 2 sides. So let's talk. Guys, on the first side, these are all percent error calculations. You've got to be able to do that for the lab. Then on the back, guys, are all the important things that you need to remember to be ready to go into lab on Thursday. So guys, with that said, go back to the first side of this. So guys, with these percent error calculations, I've given you 7. I would propose to you that if you can do a couple of these, you can probably do all of them. You know what I'm saying? So guys, here's what we're going to do. Do number 1, do number 7. If you'd like to do more of them for practice, that's fine. But in order to answer yes on Thursday when we review the homework, all that I need you to do is 1 and 7. I don't think there's any reason for you to do 7 of these because they're really repetitious. So if you can do a couple, you can probably do them all. So we're just going to do 1 and 7. You guys good? Okay, so guys, on Thursday, we will gather around this homework, and then we're going to send you off to lab. Guys, starting today, we have pride. And it seems like from grading homework today, some of you might benefit from some time with me. You're not quite settled on significant digits. You're not quite settled on rounding or scientific notation. Guys, now would be a great time to work together. As you leave today, let me know you'd like to come in during Pride today. I'll give you an eye. I'd love to work with you. But don't come into my room without getting an eye first. So guys, we have a couple minutes left. Thanks for a good morning. And lab on Thursday. It's going to be good. Just a second. Let me stop recording.